So we are looking at odds again today. We looked at them a little bit last week. We looked at them a little bit on Wednesday. But we're going to look at them a lot more today. So this first question here, suppose that at the beginning of the regular CFL season, the Saskatchewan Roughriders are given a 25% chance of winning the Grey Cup. Okay, what is the probability that the event will occur? Sorry, that's supposed to say event. Guess I could go back and fix it, but I'm not going to here. Event will occur. So the probability that the event will occur is 25%. That's a decimal, or sorry, that's a percentage. So 25%, if we wanted it as a decimal, right, that is 0.25 as a decimal. Now as a fraction, 0.25 is a really easy fraction to get. We know what it is. It's a quarter, right? You could also do 25 out of 100 and then convert it into a decimal if you wanted to, like do it that way. Convert it into a lower fraction. So start with 25 over 100 and then divide by 25, and get 1 over 4. That would also be an acceptable way of doing it. Your calculator can also turn things into fractions. So if you don't know how to turn something into a fraction, your calculator can. The way you do it is you type 0.25 into the calculator, then you hit math fraction. Okay, math, and the very first option when you hit math is fraction, enter, and it'll give it to you as a fraction. So however you want. Now the complement of this event, the word complement, same as the meaning in the very first unit. So the complement of the Riders winning the Grey Cup is the opposite of the Riders winning the Grey Cup. So remember, it's like, and it's not, I guess opposite is not the best word, but remember with sets, it's everything that isn't the Riders winning the Grey Cup. So if we're talking about the complement of the Riders winning the Grey Cup, it's any team other than the Riders winning. Okay, there's no like team that's the opposite of the Riders. Like you're not like, oh, it's the BC Lions winning. It's any other team. So all other teams. Okay, so now the complement of this event of the probability of the complement, it wants it as a fraction. So if the chances of the Riders winning is 1/4, what's the chances of any other team winning? Okay, the chances of any other team winning would be 75% because they have to add up to 100, which is 3/4. Okay, so this is kind of common sense that two events that are complements of one another have to add up to 100. So for instance, if I said you have 70% chance of passing this test, that means you have a 30% chance of failing the test, and they have to add up to 100. They're complements. Okay, now this is the part that is tricky, I think, is the odds in favor and odds against. People have trouble with odds. So like we saw the other day, people will write just like 1 to 4, and that's not right. When you're doing odds, you have to think about it. It's like chances, times you would win, winning to losing. Okay, so when I'm saying that our fraction is 1 over 4, that means that I would win 1 time out of 4 games total. Okay, that's what that means, right? Like there's 4 games in total. So if I win 1 of them, how many would I lose? Okay, so I would win 1 and I would have to lose 3. Okay, that's how odds work. So the two numbers in the odds have to add up to your total that's on the bottom of your fraction. And odds against, are just opposite. So odds against are lose to win instead. So in this case, it's 3 to 1. Okay, so if I say your odds in favor of winning are 1 to 3, what that means is that for every 1 chance you have of winning, you have 3 chances of losing. Okay, that's what it means. It doesn't mean that you have a 1 in 3 chance. Okay, those are different things. Okay, so 1 in 3 is not the same thing as 1, 2, 3. Okay, and you need to know the difference. Okay, let's look at some more examples here. Okay, so it says Bailey holds all the hearts from a standard deck of 52 playing cards. He asks Morgan to choose a single card without looking. Determine the odds in favor of Morgan choosing a face card. So here what we would do first is make a probability. Usually when you're doing odds, what you do first is make a probability. So if we have 52 cards in total, that's the number that goes on the bottom of our fraction. Okay, all the time the number on the bottom is the total. Okay, that's a good rule of thumb. Okay, so that's the total. And on top, you put the numbers that would be favorable. So here, we're talking about choosing a face card. So there are how many face cards in a deck? There's the queen, king, and jack of all 4 suits. So there's 12 face cards. Okay, so that number on top is the favorable. Okay, now 12 over 52, now you should put it into lowest terms. So 12 over 52, I could divide them both by 2 for sure. I don't know, maybe more than that. So let's try 2 and see. You could also do this on a calculator. So that's 6 over 26. Oh, so I could have divided them both by 4. So I'll divide by 2 again. Okay, and I get 3 over 13. Okay? And actually, that fraction really makes sense, I think, because you think about it, 3 out of every 13 cards will be face cards because we know there's 13 of each suit and 3 of them are face cards. So you could have gone that fraction probably faster, but that's all right. Now, when we turn that to odds in favor, what we're talking about odds in favor means face card to not face card. Okay, so it's not 3 to 13, because that's not the situation. It's face cards, we know there's 3 face cards, and then how many out of those 13 are not face cards? That's what you have to always be thinking about here, because it's super easy to just write 13 accidentally and not be thinking about it. So what it is, it's 3, 2, and if I think about it, if there's 3 face cards, that means there's 10 non-face cards, okay, number cards in this case. Okay, so the answer is 3 to 10. Okay, if it was odds against, it would be 10 to 3. So there we go. There's our odds. Okay. So here's a good question, and it's kind of interesting. This is a true statistic, I believe. Research shows that the probability of an expectant mother selected at random of having twins is 1 in 32. What are the odds in favor of an expectant mother having twins, and what are the odds against? So remember, odds in favor means twins to not twins. Okay, twins to not twins. So if the odds in favor, if the probability is 1 to 32, that means I have 1 chance of having twins. And how many chances do I have of not having twins? It's not 32, it's 31. Because for every 1 mother who has twins, there's 31 mothers who don't. Okay, so 1 to 31. And then the odds against are 31 to 1. Okay, so those are my 2 answers. Okay, easy peasy. Okay, so all the time, the 2 numbers in your odds have to add up to 31. Or sorry, 32 in this case. So always the bottom of the fraction. So always, in this case, 32, they have to add up. Okay, now here we go. We're given one more. Let's just one more of these, and then we'll be looking at easier ones. But I just really want to hammer this home because I find students have a lot of trouble with it, believe it or not. Okay, so the odds in favor of this happening. Okay, which number do I use for in favor? I would always use that top number because that top number is always favorable outcome. So odds in favor, I would put 2. And then what number comes afterwards? So remember that they have to add up to 5. So it's going to have to be 3. So that all the time, just to be really super clear, they add up to the denominator. Okay, all the time. Okay, so B, just easy, because once you do odds in favor, odds against are very easy. B is just 3 to 2. Okay, and that's all. Okay, so hopefully you're starting to get the hang of that. It's not super complicated. Okay, now here we're given odds instead, so we're going backwards now. A computer randomly selects a university student's name from the university database to be awarded a $100 gift certificate from the bookstore. The odds against the selected student being male are 57 to 43. Determine the probability that the student will be male. So this is important. There's a couple things in here that are important. First of all, the word against, the odds against, knowing that that's what we're dealing with. So the way I always do this is I like write it down. I'm like, okay, if these are the odds against them being male, that means that this number is the males. And what's this number? It's females. Okay, or it's non-males at least. Okay, maybe we could put that. So it's non-males. Okay, so we have 43 males, and that means that 57 non-males are going to be winning as well. So for every 43 chances that a male has to win, there's 57 chances for a non-male to win. So the probability then, we have to think about the total. So the probability that a student will be male, we put 43 on top because that's the total number of males. Now on the bottom, we have to think about how many total students there are. Now this adds up to 100 because it's obviously kind of a percentage thing. So 57 and 43 together make 100. So that means that it's 43 out of 100. So the probability as a fraction is 43 out of 100, or as a decimal it would be 0.43. Okay, often we'll just be representing them as decimals. Okay, sometimes it might specify, write it as a percent or whatever. Okay, let's look at one more like this. Suppose that the odds in favor of an event are 5 to 3. So now it's in favor. That's really important. Always noticing if it says favor or against. Is the probability of the event happening greater or less than 50%? So let's try it. So if it's in favor, then the number that goes on top is that first number. So I'm going to put 5 on top of my fraction. Okay, so if I put 5 on top, of my fraction, what number is going to go on the bottom? It's certainly not 3. Okay, so if I put 3 down, I will get a fraction that doesn't make any sense. I'll get 1.2, which is 120%, which really doesn't make sense. So what needs to go on the bottom, remember, is the two of them added together. So in this case, it's 8. Okay, now 8 over 5 is greater than 50%. Because 4 over 8 is is 50% exactly, so 5 over 8 is greater. So yes, it's greater. Okay, so it's greater than 50%. And that's it, pretty easy. So you just need to really keep straight the different odds and probability. Let's look at one more here. So a group of grade 12 students are holding a charity carnival to support a local animal shelter. The students have created a dice game they call BIM and a card game they call Zap. The odds of winning BIM are 5 to 2, and the odds against winning Zap are 7 to 3. So we're looking at odds against in both cases. Now it's hard to compare odds, so turning them into percents of winning is a good idea. So if it's 5 to 2 and it's against, that means 5 is the loss and 2 is the win. So my probability of winning would be 2 out of 7. Okay, now Zap. Okay, same thing. I have 7 to 3. So my probability of winning, and it's against as well, so my probability of winning is 3 over 10. Now I know 3 over 10 is 30%. 2 over 7 I don't necessarily know, so I just grab a calculator and I type it in, 2 over 7. Oh, I get 28.5%. So Madison should play Zap. Okay, and that's the answer. Okay, so that is how you do odds and you do probability. So you're going to be given a worksheet on this. You should complete that worksheet. As easy as this seems, or at least I feel like it seems easy when I'm doing it, you will find that you are easily confused at it probably, unless you're, you know, just really on the ball. So it does require practice. And on the unit test, even if, you know, you need to make sure that you've practiced recently once we get to the unit test. So give it your best go, and I will see you guys later.